Hello and welcome to Lesson 1 of Unit 6, Solving Problems with Quadratics in our Grade 10 Academic Math class. So today's lesson is sort of an overview of the types of things that we're going to be going after in this unit. I will say in advance of working through this first problem that the gist of what we're doing in Lesson 1 is recognizing that each form of a quadratic relation, whether it's factored form or vertex form or standard form, it provides us with a piece of information that if we were to graft that understanding onto a word problem, certain key values from those three forms of a quadratic relation will correspond to specific pieces of information from word problems. So this lesson, or rather this example we're doing in this lesson, and then the second example as well, you're going to get a chance to see how some of those values, some of the words that you see in word problems will correspond to particular points and thereby guide what math we're going to be doing. So without further ado, let's jump in. So question 1 says, when Mr. Smith kicks a football, it has a vertical speed of 20 meters per second and its height h in meters after t seconds can be modeled by the equation h equals 20t minus 5t squared. So part A says, what is the maximum height of the football and how long does it take to reach this height? So the thing about a word problem is that it's not going to come out and say, hey, what's the vertex? And you should do that by completing the square. It's going to point you in that direction, but you're going to need to know procedurally what to do and I guess when to do it. So the clue, and I've already underlined it and written the word vertex there, the clue to this one is finding a maximum height. This could equally be a minimum height if we were talking about sort of a different shaped parabola, something that would be opening up instead of opening down. Maximum height, biggest, highest, most, least, lowest, any of those extremes where it's talking about maxes or mins, we're looking for a vertex. And given that our equation has been provided for us here in standard form, h equals 20t minus 5t squared, and if we need to get to the vertex from here, we are going to complete the square. So that's what we're going to go after here. Now we just did some of this in 6.0, or the preparatory lesson for Unit 6, so this should be fairly straightforward. So we have h equals, I'm just going to reorder these so that I have my quadratic term at the beginning, followed by my linear term. Now it's interesting too, and I don't know that we are going to get to this later in the lesson, but there is no c value listed, which means that our c value is actually 0. When we get down to part D, and that's the part where we're going to be doing the graphing, we're going to want to remember that the height, the initial height of our football when it was kicked would correspond to our y-intercept, and our y-intercept in this case is going to be 0. So I'm going to put that on the graph right now just so we don't forget. So there it is, that's at 0, 0 is going to be our very first point provided to us from standard form. And that's the height that the football was kicked from. Okay, let's jump back into our completing of the square. And we are going to begin that by common factoring out the a value. Our a value is -5, leaving us with t squared, mind that sign, minus 4t. Now we are going to add something, we're going to subtract something to make that perfect square trinomial, and I'm not going to write down plus 0 again. So how do we figure out what value goes in there? Well, the value that goes in here is half of b, so our b value is -4, so that's half of b squared. That's going to give us -2 squared, which is going to give us 4. So 4 is going to be the value we put in to complete our perfect square trinomial. And then we are going to subtract it as well. And again, I know I say it a lot, but we included the +4 to create our perfect square trinomial, and we included our -4 here to keep our equation balanced. So let's continue on with this question. We are going to now rewrite this perfect square trinomial, and we need to deal with that -4 that's still hanging around inside the bracket. So how do we get the -4 out of the bracket? Well, we multiply it by the a value. So we're going to multiply this by -5 just to get the -4 out of the bracket. And that's going to result for us in -5 times -4 in a +20 here. And now we can go ahead and factor our beautiful perfect square trinomial. There's our plus 20, nothing to simplify there this time. Now again, this is going to start with an x. The sign inside the bracket is going to be negative since we have a negative b value. And what two numbers multiply to plus 4 and add to minus 4? That's going to be 2. So what's our vertex actually going to be here? Well, our vertex is going to be, looks like a negative 2, but is a positive 2, and 20. So because this is a word problem, we're going to tack a therefore statement on there. And we would say, therefore, I think it's asking for the maximum height of the football. So the max height is going to correspond to the y component of our vertex. It's 20 meters, and that's going to happen at the x component of our vertex, which is 2, so that will be 2 seconds. So that's how you tackle this first portion of our word problem. The max height is 20 meters at 2 seconds. We did this by completing the square, which we recognized from the clue words maximum height. Okay, let's head on to B. How long is the football in the air? So what this particular portion is asking is, it's asking us to consider, and I'm just going to scooch down to the graph again, we're going to be looking for the point at which, somewhere along this line, when that football hits the ground again. We don't know where it's going to be, but it's going to hit the ground another time. What you'll notice is that the height, when the football hits the ground again, will be at a height of 0, which is why I've sort of set up this question by saying, let's let h equal 0, and we are in fact looking for an x-intercept. So let's set our quadratic relation equal to 0, which I've done in our first line here, and now I'm going to factor it. Now this is not a difference of squares, at least visually at the moment, so let's start with common factoring. So common factoring will take out 5t. You'll notice, negative 5t. And what you'll notice is this is different than the common factoring that we're doing to complete the square. When we common factor out to complete the square, we want to leave the t squared so we can make a perfect square trinomial. Here we're trying to set up something we can solve. So how long is the football in the air? We're going to be looking for 2 t values probably. So we're going to be factoring out 1t, and we are left with t minus 4 in the bracket. Now, in order to solve for t, as we did in unit 5, I think, we are going to set each of our factors equal to 0 and solve for t. So there's the first one, negative 5t equal to 0, and t minus 4 equal to 0. And now we're going to just reorganize this. So we're going to divide both sides by negative 5, and that's going to give us t equal to 0, which interestingly enough, we already knew that one of our x-intercepts was going to be 0. It happened to also be our y-intercept. And this last one, we are going to add 4 to both sides, so t will be equal to 4. So we can see that our second y-intercept is going to happen at 4 seconds. So in response to the question, how long is the football in the air? It is in the air, therefore, it is in the air from 0 seconds to 4 seconds for 4 seconds. All right, so that is our second piece of information. The third one that we are asked to tackle is part C, and it says, how long after it is kicked is the football at a height of 15 meters? So essentially what we're asking is, and again, I'll sort of just draw it in here, we're imagining that we have this football, it's going to, well, you know what, while we're over here, let's put some points on here. So we know that, actually, let me zoom out for a second. You can actually copy down the markings that I've put on to our little quadrant 1 grid here. So once you've got this filled in, we know that at 2:20, our football will be reaching its highest point. That's right here. That's going to be happening at 2 seconds at a height of 20. And we know that this thing is going to hit the ground at 4 seconds. So we also have 4, 0 on our graph. So again, you don't have to sketch this part in yet, but we're going to see something like this, hits up here, comes back down here. So this question is asking, when is this thing at a height of 15? Now, based on the way that I've scaled this is going to be 15 here. So if you can imagine just sort of like sketching a line across, it's asking what are these times when our graph is going to be hitting a height of 15 meters. So for us, what's nice about this is that we can solve this, because we're being asked to solve. We can solve this, let me just tidy this up a little bit, by setting our equation's height, so this was previously h equals negative 5t squared plus 20t, we can set our height at 15. So we've got a height now set at 15. We're now going to reorganize this and solve. So I am going to bring 15 over to the other side by subtracting 15. And that's going to leave me with 0 equals negative 5t squared plus 20t minus 15. So now we have a quadratic. We can solve this by factoring. So let's go about that. So we have negative 5. We're common factoring that out. That's going to leave us with t squared minus 4t plus 3. And now I have that trinomial that I'm going to factor. Now, if this was not factorable, I should say before I go on, if this was not factorable, you could use the a, b, and c values in the quadratic formula to solve as well. This happens to be factorable, so I'm going to factor it. That's going to leave me with what two numbers multiply to plus 3 and add to negative 4. That'll be minus 3 and minus 1. And I'm going to set each of these factors equal to 0. T minus 3 equals 0, as well as t minus 1 equals 0. So this will equal t, or in this case t will equal 3, and t will equal 1. So the question is asking, after how long is it kicked? Is the football at a height of 15 meters? So therefore, we would say at 1 second, the football has reached 15 meters. Okay. Now I know this video is getting a little bit long, but we're going to just try to finish this thing off. We are going to include in our sketch that we've provided here the last 2 points that we've done, which is at a height of 15. We know that at 1 second we are at a height of 15, and at 3 seconds we are at a height of 15. So both of these need to be labeled height, at 3 seconds at a height of 15, and at 1 second a height of 15 as well. And I'm just going to sketch the line through that as best I can, making it curvy-ish. There we go. The other thing that needs to be labeled on here, of course, is the equation itself. So we'll go all the way back to the original one, which was h equals negative 5t squared plus 20t. We have all 5 of our points labeled, and there is our graph. So that's our first example in this lesson. Hopefully understanding what it is that we're looking for and how those particular points correspond to certain versions of a quadratic relation. Hopefully that will guide you when you're not sure what to do or when you're being asked to do something in a question. So hang in there for part 2. We're going to do one more example, and then you can go take a crack at some of this homework.